In today's video, we're going to talk about how to write the equation of a line that's tangent to some polynomial at a given value for x. It's a four-step process. To write the equation of any line, you need a point, you need a slope, then you can put it into your point-slope form, which you can then manipulate into being the slope-intercept form. So let's just take this step by step. I have my calculator with me today because I just made these numbers up 5 minutes ago. I literally don't know how big they're going to get, which is why I felt like I should go ahead and have my calculator with me. Let's start out by finding a point. We can find a point just by plugging in this x value to this function. So instead of x cubed, we'll do -1 cubed, and then minus 2 times -1 plus 7. So let's think this out. -1 cubed is going to make -1. And then 4 times -1 is going to be -4. -2 times -1 is going to be +2. Then we get our +7. -4 plus 2 is -2. Did I write 2 over there? I meant 7. -4 plus 2 is -2 plus 7 makes 5. So our point, which is an x, y coordinate, is the -1, that's the x, and the y is the 5 that we just got. That says equals 5, by the way. So it's -1, 5. All right, first step down, 3 more to go. So the next step is to figure out the slope. And did you know that in calculus, a slope and a derivative are kind of synonyms? So really what we need to do is we need to find out the derivative for this polynomial when x is -1. So first we'll find the derivative. And there's long ways to find the derivative and there's short ways to find the derivative. We'll just do the short way. Okay, so we just take these little exponents, multiply it to the coefficient, so 3 times 4 is 12, and then take the exponent, subtract 1, so 3 minus 1 is 2, so we get 12x squared. And then we'll do the same thing here. This is like a little 1 for your exponent. So just 1 times -2 is -2. Take your exponent, subtract 1. 1 minus 1 is 0, which means the x is gone. And then on a constant number, the derivative of a constant number is just 0, so just throw that out. So we have 12x squared minus 2. Now we can plug in the -1. So 12 times -1 squared minus 2. -1 squared is +1. 12 times 1 is 12. Minus 2 is 10. So what is that 10 that we just found? It's the derivative of this polynomial at -1, but more simply put, it's the slope. It's the slope. So the slope, remember slope is m, so slope is 10. It gets easier from here. And you're like, it was already easy. Yeah, and it gets easier from here. So now we're going to plug it into our point-slope form. Remember your point-slope form? And even if you don't need it, to me this is the easiest way to get into slope-intercept form in a minute, so we're going to put it in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. And the numbers that you fill in are the y1, the m, and the x1. And where are we going to get those numbers from? From the point and from the slope. So this is just the letter y. So we're going to have y minus, and then we're going to pull our y number from our point, equals m, that's your derivative or your slope, times x minus, And then we're going to pull this x1 number from our point, which is -1. And we know that this negative would become a plus. So there's our point slope form. And sometimes if the problem just asked for point slope form, you could stop there. What if they ask for slope intercept form? No problem. Just take your point slope form. You can just copy it right back down. And just solve that for the letter y. So get y by itself. So let's pick a really good color here. Green. So we will distribute the 10 in. So we got 10x plus 10. And then we will move the 5 over to the other side. So we're going to add it. So we get y equals 10x plus 15. Now, if you give me a second, I'll graph all this in the calculator so you can see exactly how cool it is. I've just typed both of our, the polynomial. Let's see if we can get this to focus. There we go. I typed the polynomial in blue, and then I typed the tangent line that we kind of created ourselves. I typed them both into my graphing calculator. So I'm going to graph it here in a second. You're going to see a blue line that's kind of squiggly. That's the original polynomial. And then you're going to see a red line come through and intersect right at x equals -1. And that's going to be your tangent line. So here we go. Let's graph this. All right. And what you can see is the blue squiggle is the polynomial. The red line is the tangent line. And you can see that they intersect each other right at -1. And if I could have zoomed this in a little bit better, you would have seen they only intersected at one point, which is the tangent point. And so that just shows you that what we found was the equation for the little red tangent line of that blue polynomial at x equals -1. To me, it's impressive. To me, that's really cool. I hope you think it's cool too. So just remember, it's a 4-step process. Get your point just by plugging in the x value to the polynomial. Get your slope by finding the derivative of the polynomial and then plugging in the x value. Then take those two pieces of information, put them in your point slope form, and then polish it off by solving your point slope form for y to get your slope intercept form. Bingo, bango, bongo, you're all done. If you need tutoring, contact me. I can tutor you in Spring Branch ISD, Katy ISD, or anywhere via Skype. Contact information is below in the description and also at the end of the video. Thanks.